What are we referring to when we talk about satellite remote sensing? This is a very old, more than 20 years, so this has changed a little bit, but it gives you a rough idea of the different applications of remote sensing and where crop management stands. When we talk about remote sensing, we're talking about detecting reflectance from soils or vegetation, which travels in the form of electromagnetic waves. And we'll see that in a minute, a little bit more detail. Are we also talking about thermal sensors, for instance? So anything that is sensed remotely falls under the category of remote sensing, and we'll be talking about systems, airborne remote sensing systems or satellite transported systems that are applied to crops. And just to give you an idea, global climate models will use remote sensing very frequently. So in the y-axis we have maybe by the hour, but they don't need very fine resolution, so maybe between 10 to 100 kilometers. On the other end, we have topographic mapping, which doesn't hardly changes, so it can be every 10 years, or more. But the resolution is very fine. Somewhere in the middle, we have crops where we will be talking about resolution between, let's say, 5 to 30 meters. And the frequency to effectively monitor and do remote sensing for agriculture will be in the terms of every 2 weeks or maybe days, but that will be the range. As I said, this is an old graph from a very interesting book about 20 years ago, Applications of Remote Sensing in Agriculture, where there was a lot of promise. Not as much as was promised, it was realized, but it was a good reference. And nowadays, this has moved a little bit, so probably crops will cover a larger circle where we have high resolution satellites, or we have aerial or even unmanned aerial vehicles transporting sensors. And that's also giving us the freedom to, so we have lower resolutions and we have also higher frequency of data capture, and that is expanding the scope of applications for crop management. So this is a reference graph which gives a good idea of where we are. And let's go through some basic principles. And before we go in there, let's see if there are any questions. Not yet, so just feel free to enter a question in the chat window. So basically, as we said, we are going to in this course, we're going to work mainly with reflectance of the soils and vegetation. There will be commercial applications for thermal and for maybe other types of sensors in the future, but really mostly what you see in the market is measuring reflectance of the soils and vegetation, and this reflectance travels through electromagnetic waves, and which has different length of waves. So you have, according to that length of wave, we have different a classification of those waves. In the visible region, we'll have a narrow. So this is measured in, I think it's in nanometers. You have the visible region. And what we'll be doing with remote sensing for agriculture will be detecting the ranges of waves, and with maybe 5, maybe 6, maybe 7 bands of wavelength. So basically, we're measuring different bands of wavelengths, and we'll see how this connects to reality. And based on those ranges of wavelength, we can demonstrate that different crops will have what is called different spectral signatures, or how they reflect the different bands or ranges of wavelengths. So we can differentiate different types of crops. We can differentiate soils. So that's basically how we can recognize crops using remote sensing. And this spectral signatures will also have variation depending on if there's water stress, if there's early in the crop season, if it's late. Based on this principle, we can find out different aspects, different applications for remote sensing.